Hello everyone and welcome to today's video where we'll dive deep into the world of C++ libraries. In this video, we'll explore the importance of C++ libraries, how to use them effectively, and provide you with some practical code examples to get you started. So, if you're ready to supercharge your C++ projects, let's get started. Before we jump into the code, let's grasp the essence of C++ libraries. Think of them as pre-written sets of code that address common tasks and provide a wide range of functionalities, such as handling file operations or performing complex mathematical calculations. C++ libraries are an essential part of C++ programming. Now, you might be wondering, but why are they important? Well, C++ libraries help you save time and effort by allowing you to reuse existing code rather than recreating or reinventing the wheel, because it's neither efficient nor practical. In providing ready-made solutions, they allow us to focus on unique aspects of our projects. This not only speeds up the development but also ensures that you are using well-tested and optimized code. Additionally, libraries can provide more powerful features that are otherwise complex to implement from scratch. Now, think of it like this. A computer is a machine and you're a human being. And in order for you to communicate with it, say you want to output your string, would you now want to recreate the function or the communication language to say, this is how you computer will now display my output string? But then with the library IOStream, you've got the function cout that provide all your output functionalities. Now let's talk about how to use your C++ libraries in your own projects. To use a C++ library, you typically include the library's header files at the beginning of your code using the hashtag include derivative. The hashtag include preprocessor derivative in C++ is used to include the contents of a file into the current source file, or in this case we can say that to include the file being that library. And this allows you to include files that contain common or frequently used code, such as functions, classes, and definitions, and your libraries. Then you can access the functions and classes provided by whatever specified library in your code. Let's put this into action and with some real-world examples. So for our first code example, we'll be using the IStream library. So IStream is a standard C++ library that provides an input and output strings. It stands for input output string and is part of the standard C++ library. Now here we include the IStream library to work with input and output, as already mentioned. And here are some of the key components of the IStream library. The cin function. Now this function is an instance of the IStream class, which is used for reading input from the standard input device, usually the keyboard. So we'll include it on our code example. Hashtag include IOStream. Great. And for example, we said for the first example, we'll be using cin. Say maybe you need to enter your age. Obviously, we need to declare this age so that the compiler knows what function, what variable this is. And then let's run this to see. Let's just call it library. The compiler requires for us to enter input, but obviously you won't be able to see that is the input prompt. So another function that the IOStream library provides for us is the cout function. Now this function is an instance of the OStream class and it's used for writing your output to the standard output device, usually your console. So that you're able to see what this is, we're going to provide output, and the cout function enables for us to print out output. Now think of it as this: if we did not have this IOStream library included, we'd have to find a way to tell the compiler that whatever this enter your age is an output and it should print it, and not maybe you want it for us to enter it or something else, and the cin is the input that the user should enter. Say maybe cout. Now the compiler will know that you are age So now the compiler will know that this one, whatever that comes out after this, you output it. But then whatever that comes after this, it's an input that the user should enter into the console. And whatever that comes after this, it's an output. So the compiler understands it better because there are already good programmers that helped us and created libraries for enabling for us to be able to write this efficiently. So now when we run this, let's just check to see if there are no errors proper. Now when we run it, we do see that we get the entire age because it runs from the function cout and the cin, which prompts input from the input, and then you are 18 years old. Great. Another function provided by the IOStream library, insertion and the extraction operator. The insertion operator is used for writing data to the output stream, and the extraction one is used for reading data from the input stream. As you can see, our operators here, the cout has your extraction operator and the cin has the insertion operator. Now let's tackle complex mathematical calculations using the CMath library. The CMath library provides a number of mathematical functions such as cos function, a sine function, a logarithmic function, and many more. These functions can be used to perform your common mathematical operations like finding the cosine of an angle or the natural logarithmic of a number. So we're going to use an example where we want to square a number or whatever power of a number you may want. So let's clear off whatever we have here. CMath library. And for our first example, we will use the squaring of numbers. So let's declare whatever number we will use. We will just prompt the user to enter the number they would like to square. Now to square it, you just basically need to declare the value that will hold the squared number. And then we now give it the calculation number. CMath library provides a function called pow. With pow, you can raise this number to whatever value you want. Now if you wanted to raise it to 1, you just put the 1 there. And if you wanted to raise it to 2, by squaring it, you can put it there. And if you want to cube it, you can cube it as well. So let's just square it because the prompt was to enter the number to square. And remember to output run. Our cout function tells us, okay, enter the number to be squared. Let's take 6, which we know by head that it should give us a 36. Try out with another number. 5 should give us a 25, right? 25. Now let's try. Say maybe you had a very complex one, like maybe the logarithmic of a number. You can get the log of a number simply by just writing log, because it's already a predefined function within the CMath library to tell you can get the log of a number. Log of 1. We know that the log of 1 is a 0 and proves us correct. Now we see that with CMath we can effortlessly handle all our mathematical tasks. We will move on to the IOManip library. Now the IOManip library stands for Input Output Manipulator. IOManip provides a number of manipulators that can be used to control the formatting of output. For example, you can use IOManip to set the precisions of floating point numbers, to set the number of decimal places, and to specify the alignment of data in the output. Now, here are some commonly used manipulators from IOManip. Let's take set width, for example. Set width says the width of the next input or output field. This is often used to ensure that a specific minimum width of input or output. Let's give it a try. We can remove whatever we have in here and let's declare our library. Suppose you have a list of names and surnames which you want to output and you want them to be properly aligned. Let's say, let me open up a notepad just to. Right, suppose you have something of this form. You've got names, list of names, and surnames, and you'd love to have, say you've got this name which takes up this length, and then you've got this surname which takes up this length, you've got this name which takes up this length, the surname. You see, it looks a bit not untidy. So what if we would love to have them all be in such a manner that they are like this? So set width would enable you to say whatever that comes on the side, the width would be 250, and then so this whatever that comes after this would now be start off from after the 50 width. Great, let's try that out. Look at how untidy this is, and worse, there's not even spacing in between. You don't know where are surnames, so it would require you to put up a lot of spaces in between there. It would just be complex. Put up the set width function. Right, now let's try it out. Great. So what happened now here, if you could see closely, you could see that from this point, this is where our names end, because this is where the width ends. Like, we have the alignment that we want, just that we don't have the spacing. So because by default, the naming takes up the right adjustment. So but then fortunately, IOManip contains another function within it that enables us to format these names to the left of the console. Put this to the left. Now you can perfectly see that these names were given a width of 20, and they were aligned to the left. Now there's no manipulation which is really done to the surname side of things. We could set that, you could tell the compiler that for whatever that is left on this width, you could put up stars or maybe whatever that you want. And there's a function. This function is called setFill. We had stars. So setFill is one other function found within the IOManip function. I only did it for the last name we have on our compiler, and you see it did not affect anything on the side. I mean, like, this is just to fill up whatever we have on here. Within the IOManip function, there's so many other functions, including your set precision, which sets the precision number of decimal places to a certain floating number points, and there's a whole lot more. In the next video, we will look at creating your own library. Yes, that is possible. You can create your own C++ library. This can be a collection of classes, functions, or other code that you want to reuse across multiple projects. Here are most commonly used standard C++ libraries. We've got your IOStream, which we've already used in our code example, and this is used for your input-output operations, where we had your cin, cout, your insertion and the extraction operator, and so many other more functions you can find within the IOStream library. And there's number 2, and this one enables you to manipulate your string. And the next commonly used standard C++ library is CMath, and one other most commonly used standard C++ library is CTime. This is a C standard library, and it provides functions for working with your dates and time. It includes functions for getting the current time, formatting your time, and manipulating time values. And one other commonly used library is your stdlib. This one is a general purpose library. It's short for standard library, and it's a core part of the C and C++ programming languages. It provides a collection of functions, macros, and types that are essential for basic operations like your memory allocation, random number generation, type conversion, and other common tasks. Now, there are numerous C++ libraries available for various purposes, including Boost, OpenCV, and SFML. The choice of library depends basically on your specific project requirements. One library you'll really get cozy with is the Standard Template Library, or STL for short. It's a collection of containers and algorithms that streamline complex operations like sorting, searching, and managing data structures. And it's what we've been using. They are standard to C++. With every compiler you have for C++, you will have them within there, as long as you do declare them on the compiler to say #include this and #include that. Also, it provides a lot of functionality that's useful for many different programs. And another popular library is Boost, and this one provides many useful algorithms and data structures that aren't included in your C++ standards. These libraries can be easily incorporated into your C++ program. Now, the Boost C++ libraries, they are a collection of high quality, peer-reviewed libraries that extend to capabilities of your C++. They cover a wide range of areas, from multi-threading to networking, providing robust solutions for various applications domains. That's a lot. One last other we're going to look at is OpenCV. It's an open source computer vision library, and it's used for a wide range of applications, from a simple image processing to complex machine learning. The use of OpenCV library extends to computer vision, SDL for game development, and SQLite for database management, just to name a few. One of the most popular uses of OpenCV is for object detection and tracking. It can be used to identify and track objects in a video or a series of images. It can also be used for image enhancements and segmentation, as well as motion detection and tracking. There you have it, folks. We have explored the world of C++ libraries, learned why they are indispensable, and even divided into some practical examples. And that wraps up our exploration of C++ libraries, their importance, usage, and code examples. Remember, libraries are your programming best friends to have efficient and robust C++ code. So make the most of them in your C++ projects. If you found this video helpful, don't forget to like, share, and subscribe for more programming tutorials. See you on the next video.